So here we have a problem that deals with stationary wave patterns. Let's start off with this question here. You're asked, state what is meant by an antinode of the stationary wave. So basically, an antinode of a stationary wave is the maximum displacement of the wave. Okay. Now for the distance between a node and an adjacent antinode, if we're gonna try to look into here, right? An antinode and an antinode is basically half a wave, right? So let's see. That's 1/4 and 1/4. That's basically 1/2. So this is an antinode. This is the node. So from there, this gives you 1/4 of a wavelength, right? And of course, from antinode to antinode, that gives you 1/2 of the wavelength. So if this is 1/2 and this is another half, right? This one full wave, and this is another half. So this one 1.5 waves. So what would now be the distance of that value? So if you look at it, 0. Right. If you're gonna try to divide this by 1.5 waves, you will get 0.4. That will be the wavelength, right? Divided by 4, because you want to find out the half of the wavelength, that leads to 0.1 meter. So for the wavelength itself, as I mentioned, that's gonna be 0.6 divided by 1.5, that leads to 0.4. That is the wavelength of the wave that we have here. Now, if going here, you're solving for the frequency, that now would lead to um, F equals to V over lambda. So that's 340 divided by 0.4. 340 divided by 0.4. That gives you 850 hertz. Now, 850 hertz is for this pattern that you have here. Okay, the pattern would look something like this. Okay, try to do the pattern. Okay, so there you go. That's the pattern. So antinode on that side. I would assume antinode here on the other side as well. Now, what would be the minimum frequency that you can have? The minimum frequency that you can have in an open tube is almost the same as your uh, closed tube plus one. So if you have the fundamental, basically, if we're gonna try to have the minimum bear here, without the pattern, then you should have something like this. Okay, 1/4 and 1/4. That's half of a wavelength, right? So if we're gonna do that in terms of L, in terms of lambda, that will be lambda equals to twice the value of your length. So if that is the case, that's 2 times 0.6. Okay. Then of course solve that using your proper value. So that's 340 over 2 times 0.6. 340 divided by 2 times 0.6. Right, you will get 283 hertz. So this is now your simplest loud sound that will be produced with a stationary wave for this problem. This is how you solve this question.